following is a discussion and live demonstration for the isotrol active tracking filter technology and other associated technologies available on the market today. First, we have the Isotran Power Window Line Analyzer, which we offer to allow a customer to actually analyze the power line disturbances in their own facility. You simply plug this into an outlet and you can monitor the noise and frequencies of high transient amplitudes that are available on your power line. And that shows you indeed that even in this facility there are transients and spikes apparent. Next, we have the Isotrol Spike Transient Generator, model TS4, that will actually impose a couple 600 volt peak-to-peak spikes on the sine wave. Here on the oscilloscope, you can see the spikes imposed not only at the peak of the sine wave, but also at the zero crossover point. Significance of the zero crossover is that many electronics in the industrial motion control circuits use the zero crossover as a timing sequence or sync, and obviously if you have a spike around the zero crossover point, you can see that it could very easily disturb that timing process itself. So the whole point is that we're trying to look at technology that will eliminate surges or spikes anywhere on the sine wave. I'm putting these spikes on the sine wave through this test box, which represents the various technologies available in the market today. The first position, or position 4 here, is a metal oxide varistor, or MOV for short, which is a surge clamping component or surge clamping technology. Basically, the way an MOV works, it's wired around the power line and does nothing unless it sees a very high voltage transient, in which case it clamps it. The next position on the test box is an EMI or RFI filter, and basically these filters are meant to reduce any noise that an piece of equipment itself would generate back onto the power line. Unfortunately, a lot of people believe that because it's bidirectional, it would also reduce spikes or transient activity coming into the equipment. But the filter by design is meant for very high frequency, low energy RF type noise, and the type of transient activity we're talking about in reference to IEEE, such as the Emerald book, which discusses transients in great detail over several years of study, is much lower in frequency than those type of energies that the RF filter, RFI or EMI filter is meant to attenuate. To actually demonstrate that, again, I have the transients coming into the EMI filter, and this switch on the TS4 actually allows me to look at the input and the output of the filter itself. So here we're looking at the input, and when I throw this switch, there you're looking at the output. That's the input, and that's the output. You see there's virtually no difference, which is not surprising because, again, the transients generated by this generator, in reference to IEEE Emerald studies, is much lower in frequency than the EMI filter was originally intended to attenuate or reduce. The next position on my box here is the Control Concepts Active Tracking Isotrol Filter. Inside the box is a 1 amp device. Here we have a 2.5 to 5 amp device, and here we have a filter up to 20 amps and a DIN rail feature. And basically they're all the same technology, they're all low pass filters, similar to the EMI filter, but that's where the similarity ends. Because where the EMI filter is meant to attenuate very high frequency noise and low energy RF type noise, it would have a cutoff of several hundred kilohertz. Our filters have a frequency cutoff that begins around 3 kilohertz. So as you can see, it's very close to the sine wave and virtually allows the sine wave through undisturbed, but attenuates just about any noise, spikes, or transients after that. To demonstrate that, here we have again the input to the isotrol filter, and you can see the same spikes we've been referencing. And when I throw this switch, you can see the spikes are virtually eliminated. And notice not only on the peak of the sine wave, but also at the zero crossover point, or virtually anywhere on that sine wave, because it is a frequency-based technology, not a surge clamping technology like the MOV. Again, that's the input to the isotrol filter, and that's the output. So this demonstration readily proves that to totally remove any surges or spikes or transients on your sine wave, that you really need the power and the technology of isotrol active tracking filtering.